Hello everyone, welcome to this particular video wherein you'll understand the fundamentals of programming and fundamentals of a computer. Most of the programming aspirants fail to understand any of the programming language or programming in general because they directly try to understand the concept of programming by considering a big program and then trying to understand different components such as variables, functions. If you ask me, that is not the way to learn programming. If you want to evolve in IT industry and if you want to become a versatile, wherein in future you want to understand different programming languages as per the demand and situation, first you must understand the fundamentals of programming so that in future, as per the demand and situation, you can go and learn any programming language you want. For which, first in this particular video, we will try to understand something very fundamental of programming and computer in general so that your foundations are very strong. To start with, I would be considering this lecture with the concept of computer. If I ask you what is a computer, just tell me different components of computer in general. You would be saying that it is CPU, microprocessor, or you can say processor, CPU, all of them are same. Of course, then you'll say monitor, different major components such as RAM, hard disk, keyboard, mouse. All of these are different components which is a part of computer. Of course, these days computers are in different form. Your mobile phone is a computer. Your laptop is a computer. Your desktop system is a computer. Fine. So in this computer, which is the most important component if you ask me, that is nothing but your processor, for which generally we call it as CPU, which is the brain of your computer, which I would be representing in this style. This is the CPU, or you can consider the brain of your computer. The brain of your computer. I can call it as CPU. Whatever happens in your computer, this processor is responsible for it. If you are able to play the music, processor is responsible to execute that. If you are able to dial a number to your friend to call, processor is responsible. Anything, everything which is happening in your machine, in your computer, this processor is the responsible one. But something fundamentals about this processor you must understand. What is that if you ask me? This processor is of one technology called as semiconductor technology. Semiconductor technology. Now, do we need to learn everything about semiconductor technology? Not required at this stage. But something fundamental about this technology you must know. Number one, that it is very fast in its execution. Number two, any device which is making use of the concept of transistors, capacitors is called as semiconductor technology device. If I say the most important component of your computer, the brain of your computer is a semiconductor technology device, that means transistors are being used to manufacture this processor. That is the conclusion. Fine. Now, about the transistors, do we need to know so many things? Not required. Fundamentally, you might have heard transistors are of two types, NPN, PNP. Do we need to understand everything about this? Not required. But one thing you must know about transistor is it is such a device which understands only two things. What is that two things? Number one, it can understand either low voltage, which you can represent as 0 volt, or it can understand high voltage, which I'll be representing it as 5 volts. Fine. Now, if I say that my CPU processor is of semiconductor technology device, that means transistors are involved to manufacture this processor, and transistor understands only two things, either low voltage and high voltage. In software engineering world, low voltage and high voltage can be represented as 0 and 1. Binary 0 and 1. Now the conclusion is the most important component of our computer, the brain of our computer processor, is of semiconductor technology device, because of which transistors are being used to manufacture it, and understands only two things, either 0 or 1. And one more thing, this processor is a dumb device. It cannot do something by itself. You have manufactured this device so that you can get some work out of it. I have manufactured this. I want my processor to do some activity for me. It cannot do something by itself. If you want your processor to do something for it, then you have to communicate. You have to instruct to do. Now, I am able to communicate with you in English because you understand English, and whatever I am able to say, you are in a position to understand that. In a proper format, in a human understandable format, I am using one of the native language and trying to convey my message, trying to instruct you. Similarly, if you want this processor to do something for you, then you have to instruct it. And how will you instruct? Will you instruct in English? Will you instruct in any other language? No. You have to instruct in a way which your machine understands. Example, I want my processor to maybe add something. I will write here 0, 1, 0, 1, 0, 1. I want my processor to perform subtraction. I'll write here 1, 0, 1, 0, 1, 1. I want my processor to perform multiplication for me. I would write here 0, 0, 1, 0, 1, 0. I want it to perform division for me. That is also one activity I want my processor to do. I'll be writing here 1, 1, 1, 1, 0, 1. Of course, these are not the exact instructions in the binary form to do this activity. For an instance, for an example, I've taken this. Now, writing the instructions in a form which your machine understands, technically we call that as a machine level language. We call that as machine level language. That means writing instructions in binary form or in a form which your machine understands. Now, all these instructions I'll be writing in one place here. All these instructions I'll be writing in one place. Instruction number 1, 2, 3. Set of all instructions is only we call it as program. What is program? All instructions, addition, subtraction, multiplication, division in one place, we call it as a program. Now this program, how have you written? It is written in the form of machine level language, in a form which your machine understands. And now if I give these instructions or this program to my processor, will it understand and give me the desired result? The answer is yes, it will understand, and whatever is the desired output, you will be getting that. Fine. Now all the humans are very happy. Wow, we are able to make or manufacture such a device. If we are instructing, it is doing its task and giving us the result. Fine. But the approach to instruct your machine is not human friendly approach. It is in the form of binaries, zeros and ones. For a humans, it's not easy to remember the numbers. Suppose if you are writing a small application, if you are developing a small application wherein instructions are very less, somewhat you can manage using the zeros and ones. What if the application is very large, wherein you have to write lots of lines of code? How will you write using zeros and ones? If there is any error, you have to rectify which 0 to rectify, which 1 to rectify. In other words, writing instructions in binary form is not human friendly. That is when, after some of the evaluations, some of the research being done, we came up with an approach wherein we said, why to write instruction this? If you want to just add, I will just say here add. For subtraction, need not write these many instructions, just tell sub. For multiplication, just mul. For division, just div. In other words, writing instructions in the form of mnemonics. Fine. Now, comparatively, from the machine level to mnemonics, which is better for humans? It is the mnemonics. And writing instructions in the form of mnemonics, we call that as assembly level language. Now, if you have an option to write programs in the form of machine level and assembly level, which one would you prefer? Of course, you would go with the concept of assembly level language, which is more friendly, more human friendly. Now tell me, this program, this instructions which you have written in assembly level language, if you give it to your processor, will it understand and give you the desired result? The answer is no. Why? Because processor understands only one thing, zeros and ones. And now you are telling in the form of mnemonics, add, sub, mul, div, what it can understand? Processor says, hey, you have made me, I can understand only zeros and ones. I cannot understand this mnemonics language or assembly level language. Now that is when they came up with one option. They came up with one system software which is named as assembler. Which is named as assembler. What is the duty of assembler if you ask me? Assembler is such a system software which converts your assembly level language into machine level language or binary form. It's a system software which just converts the mnemonics into zeros and ones. And that zeros and ones binary code, if you give it to your processor, will you get the desired result? The answer is yes, 100% you will get it. Now, are we using mnemonics form of writing the instructions or writing the programs? No. Again, this is also not so human friendly. Of course, comparatively, if you compare with the machine level language, this is a better approach, no doubt about this. But again, here also there are a lot of difficulties. If you are from the engineering background, if you have come across subjects such as microcontroller and microprocessor, you will agree with me that writing instructions in the form of mnemonics also not so friendly. That is when, again, after doing the research, it was almost 1960s, again lot of research, computer scientists told, hey, why to write the instructions in mnemonics? Let's use symbols. For addition, just plus symbol. For subtraction, this symbol. Multiplication, symbol. Division, symbol. Not just symbols, using the English-like commands. Example, print. Print means print. Scan means scan. If means if. Else means else. The demand of writing, programming or instructing in using the concept of symbols and English-like commands came into picture. And this approach we started to refer as high-level language. Of course, under the category of high level, there are many things which I don't want to get into right now. In general, this is the approach wherein you can use symbols and English-like commands to write the instructions or in general to write the programs. Now, if you have an option to write instructions or program in machine level or assembly level, all this high level wherein you have option of English-like commands and symbols, which approach would you choose? Of course, you would go with this English-like commands and symbols. Now, it was 1960s. We started to write the instructions. In which style, if you ask me? In a style wherein you are using English-like commands and symbols. You can call it as high-level language. Now, if you have understood so far, tell me one thing. If you give this program to your processor, will it understand and give you the desired result? The answer is no, because your processor understands only zeros and ones. That is when they came up with an approach, one system software. Name of the system software is compiler. Name of the system software is compiler. What is the duty of compiler if you ask me? Compiler is a system software which converts your English-like commands into machine level language, zeros and ones or binary form, which machine can understand, is only called as compiler. Such a system software which converts high level language into machine level language or binary code which our machine understands. And if you give this zeros and ones binary code to your machine, will it give you the desired result? Yes. From then, almost from 1960s. Even today, to instruct to write the programs, we are using English-like commands and symbol, which is quite easy when you compare with the mnemonics, assembly level language and machine level language to write the instructions to write the program. All the programming language comes under this radar only, be it C, C++, Java, which we are going to learn. I hope now you'll understand why we need to compile it, because our machine can understand only zeros and ones. And from 1960s, even today, we are using the English-like commands and symbols to write our programs, to write the instructions which our machine can understand and give you the desired results. I hope with this you have fundamentally understood how programming started and what exactly is the programming or writing the programs means. Of course, in the upcoming videos, we'll try to understand more on the fundamental concept so that your foundations are very strong before we start to write programs in Java. Thank you so much for joining me in this video.